The urban environment is a mosaic of adjacent forms and surfaces with a unique spatial morphology that gives rise to distinct meteorological conditions. The urban climate and its study are becoming increasingly important as these regions show significantly higher rates of population growth and development, which will exacerbate the environmental challenges that are already present. Driven by the desire to understand and simulate the environment as a holistic organism, ENVI-met, a microclimate simulation software, was developed based on objective scientific methods so that the effects of proposed architectural and planning solutions are measurable. ENVI-met is a holistic three-dimensional model used to simulate complex urban environments and to assess the effects of green architecture visions. It is designed for a wide range of temporal and spatial inquiries and can reveal credible differences in urban geometry by capturing their impacts on microclimatic conditions. ENVI-met includes the capacity to analyze a wide array of spatial scales, from systems as small as a courtyard to as large as an entire city, depending upon the goals of the project. To create sustainable and resilient living conditions, this software will help to minimize heat stress, air pollution, and wind risk by providing up-to-date numerical simulation techniques to elucidate the impacts of our architecture and planning proposals on the urban fabric in a fashion that goes beyond intuition and assumption. There is an endless variety of building and ground plane material options made available through the ability to specify parameters such as thickness, albedo, specific heat, density, and many other factors. The software also enables the calculation of wind dynamics in complex urban settings to illustrate the fluvial impacts of different urban design decisions, which can be used to inform ventilation or pollution dispersion. In order to integrate ENVI-met into existing workflows of industry professionals, recent updates open a new chapter in how users can construct models and simulate data. Moving away from grid-by-grid editing, MOND enables vector-based approaches that make it easier to generate models or to change spatial resolution with just one click. Users can import existing vector data, such as CAD and GIS shapefiles, in addition to accessing the worldwide database of OpenStreetMap and OpenTopography to create ENVI-met models. With the application of vegetated infrastructure on roofs and walls becoming an important tool in green building design and urban planning, ENVI-met's new green wall module enables the user to accurately simulate the complex interaction of vegetation, substrate layers, and fixation materials mounted on facades or roofs. In order to produce valid results, the modules take into account a multitude of parameters, including the opening and closing of stomata based on the validated plant model and the effects of multiple reflections and local infrared radiation. With Albero, the user can simulate complex three-dimensional plants and manage both their properties and appearance. This also enables the creation of new plants to emulate specific species of interest, accounting for features such as root shape, canopy size, leaf area index, leaf albedo, and the ability to distinguish between evergreen and deciduous species. The new ENVI-met plugin for Rhino Grasshopper has been developed in the Ladybug tools. This plugin enables users to convert Rhino 3D designs to ENVI-met model areas and run simulations without even opening the ENVI-met software suite. Since our users are typically already experts in their core applications, this makes it easier and faster for professionals to adopt these tools. In order to mitigate the impacts of climate change and population growth, it is important that we no longer operate using trial and error, but instead be more critical of site performance. A more holistic approach can resolve the dynamic interactions between plants, buildings, and the atmosphere to quantify site-specific environmental performance metrics. The future of architecture and planning is here. It is time to elevate the design process to a new level.